Yeah. Uh, Hello, everybody. Welcome. And this is an introductory session about Hadoop and big data. Yeah. Let me start. Okay. Now, before we start, let's have uh, the objectives. What is big data? The problem with big data, and what is the solution to the problem about big data, and what is Hadoop? Hadoop versus other systems. So this is the agenda about this introductory session. Okay. Now, big data. What is big data? High volumes of data is considered as big data. When I say high volumes, it's generally in petabytes or more. We can consider it as big data. Okay. So high volumes of data is called big data. Petabytes or more in size. Next. What are the sources of big data, or where do we get the big data generated from? There are various sources which generate big data. Let's say search engines like Google, Yahoo, okay, and social networking sites like Twitter, Facebook, okay, and server log files, something like web server log files, etc. These are all various sources about big data. Okay, stock exchanges, okay, Twitter, Facebook. These are all the sources of big data. Now that we understood what is big data, how is big data generated? Okay, how is big data generated? Let's understand what is the problem with this big data. How does the big data affect us in our day-to-day life? What we have to do with the big data? Let's say I have a lot of data available in the web server log files. Okay, what do I do with the web server log files? Okay, I can study the records inside the web server log files. Okay, the problem with big data is storage and analysis. Storage and analysis. Okay, so that is the problem with big data. So we should have a reliable storage and analysis system. Okay, I should ensure that data is not lost. Okay, and at the same time I should have a system where I can process the data to find the proper results which can be used to improve the business. Okay, so that's a problem with big data. Okay, so I have the big data. What do I do with this big data? Okay, next, solution. The problem to the big data solution, the solution to the big data problem, sorry for that, solution to the big data problem. How can we solve the big data storage and analysis is the question. Okay, so here, to solve the storage problem about the big data, we need to store the data on multiple machines on a cluster. We need to store the data on multiple machines on a cluster. And for efficient processing and faster processing of the data stored on multiple machines across the cluster, what we need to do is we need to read the data simultaneously across all the machines on the cluster, so that we can quickly read and process the data stored on the cluster. Okay, so to solve the storage problem, we can store data on multiple computers on a network, and for efficient reading and processing, we read data simultaneously. Okay, so this is the solution to the big data storage and analysis. So far we understood what is big data and what is the problem with that big data and what is the solution to that big data problem. Right? Next step. What is Hadoop? Hadoop is an open source framework and infrastructure which is used for reliable storage and processing. I repeat, Hadoop is an open source infrastructure and framework which is used for reliable storage and processing of big data. Okay, so that is the definition about Hadoop. Okay, so here Hadoop is generally identified with the logo of elephant. Okay, so now Hadoop has various components for efficient storage and processing. One of the components of Hadoop which is used for efficient storage, reliable storage, is called HDFS, Hadoop Distributed File System. Okay, Hadoop Distributed File System is a file system which is used to store data on multiple computers across the cluster. Okay, HDFS manages replicas of data in order to ensure that if one machine on which the data is stored goes crashed, we still want the data available. So due to that reason, HDFS manages multiple copies of the data. Okay, in one sentence, HDFS, Hadoop Distributed File System, is the storage mechanism used by Hadoop for reliable storage. Okay, so that is HDFS. You can have an idea about HDFS in the picture. We have data nodes. Okay, so data nodes contain blocks. Okay, the blocks contain the data inside which. Right, clients interact with the machines on the data nodes. Okay, for reading and writing purposes. Next step is MapReduce. What is MapReduce? MapReduce is the Hadoop's programming model or processing model. Hadoop uses the programming model called MapReduce to efficiently read the data stored in HDFS file system. So MapReduce is a distributed processing model which reads data parallelly from across the machines stored connected to the cluster. Okay, so that is how the MapReduce is used. For efficient parallel processing of data stored on HDFS, Hadoop uses the programming model called MapReduce. MapReduce is a powerful programming model which has many benefits. Okay, it automatically looks after the failed machines and recovers them without the human intervention. Okay, so that is about MapReduce. Okay, next, Hadoop versus RDBMS. Why cannot we use RDBMS? Why should we go for Hadoop? So we have differences like comparison between RDBMS and Hadoop. RDBMS stores structured data, whereas Hadoop can store structured data, semi-structured data, unstructured data. Okay, in case of Hadoop, the data is not normalized, whereas in case of RDBMS, data is normalized. The capacities in RDBMS is GBs, gigabytes. The capacities in Hadoop is petabytes or more. RDBMS is best suited for writes and updates, whereas Hadoop is best suited for write once and read many times. One situation where RDBMS is suitable is I store an employee record today. Okay, his employee details or employee number, employee name, designation, and salary. Few days later, the salary of employee is hiked. That means in RDBMS, I can make a modification to the employee record. That means in the initial days, I write a new employee record into the database. After a few days, I modify the same record. So this is a situation wherein RDBMS is used. Okay, but coming to Hadoop, Hadoop is best suitable for write once and read many times. When I say write once and read many times, we can consider a web server log. Okay, a web server log keeps tracking the client details about which client made a request to the server and how many times, at what time, on which date it made a request. Modifying the web server log does not make any sense. Modifying the web server log does not make any sense. So we need to process the web server log and figure out how many times a particular client has made a request to the server, so that we can use that data for improving the server's functionality for launching a new server at a particular location. So that is the fundamental difference between RDBMS and Hadoop. Hadoop is used for write once and read many times, wherein the web server log data is written only one time, but it is processed many times. RDBMS is used for writing and updating, frequent writes and frequent updates. Okay, and Hadoop data is not normalized, whereas RDBMS data is normalized. Okay, coming to Hadoop and other technology called high performance computing, HPC. HPC or high performance computing also functions the data processing in a way similar to Hadoop, in the sense it processes data on more than one machine. But the challenge in high performance computing is data is stored on one central computer. When data is stored on one central computer, obviously it has to be moved to many machines which have the code, which have the processing code in them. So here we can see the difference between high performance computing and Hadoop. In case of Hadoop, data and processing tasks are on the same machine, HDFS, which store the data here, and the processing tasks are on the same machines. But when you see high performance computing, the data is stored on central storage server, and all the nodes will need to read that data from the central storage. Okay, so here that means the processing nodes have to read the data from central storage, and they have to wait until the data is read to their machines. So here the data that is transferred from the central storage to the processing nodes, from the central storage to the processing nodes, is in gigabytes or terabytes or petabytes, okay, which takes a lot of time. So here a lot of time is wasted in case of high performance computing to transfer data from central storage to the processing node. The benefit in Hadoop with the same is Hadoop uses local data. That means Hadoop stores data and the code, processing code, on the same machine. So there is no chance of wastage of time. Okay, that is the first difference. Okay, in case of HPC, moves data to processing nodes. In case of Hadoop, moves processing to the data nodes. In case of HPC, failover detection and recovery is manual. In case of Hadoop, failover recovery is automatic. And in case of HPC, as we're able to see, inter-process coordination is manual, and in case of Hadoop, inter-process coordination is automatic. That's about the basic idea about Hadoop and big data. Okay, thank you everybody.